Some circuits have multiple EMFs. Let's use Kirchhoff's second law on each of the following. A battery of 2 cells, 8 volts and 2 volts, and 2 resistors of resistance R and 3R in series. The sum of the EMFs is 10 volts, so R has 2.5 volts PD across it, and 3R has 7.5 volts PD. Move one cell between the resistors, and we find the order is not important. The sum of the EMFs is still 10 volts, so R has 2.5 volts PD and 3R has 7.5 volts PD. If we turn one cell around, the sum of the EMFs is now 6 volts, so R has 1.5 volts PD and 3R has 4.5 volts PD. If we place one of the cells across one resistor opposing the other cell, now we have to think about loops. For one loop, the sum of the EMFs is 2 volts, so R has 2 volts PD. For another loop, sum of the EMFs is 8 volts, so R has 2 volts PD and 3R has 6 volts PD. And if we now consider the third loop, the 8 volt cell is placing 6 volts across 3R, so the 8 volt cell must be placing 2 volts across the 2 volt cell. Since the two cells are opposing, this means no current flows through the 2 volt cell.